Hey everyone, Mr. Markwick here. The purpose of today's video is to show you how to solve simultaneous equations using a graphics calculator. Hopefully you know what I mean when I'm saying solving simultaneous equations. Essentially, what I am talking about is we're looking at a pair of equations, or maybe more, but in this instance, two equations, which represent straight lines in this case, and solving them is finding their point of intersection. So for example, if I drew those straight lines on a Cartesian plane with my x and y axes, what I'm talking about is where one line crosses and meets with a second line. Okay, so what is their point of intersection in terms of perhaps a set of coordinates, an x and a y value? Okay, so when you're solving simultaneous equations, it'll either be written as a set of coordinates, or you have a value x equals a value and y equals a value. Okay, so that's what I'm talking about when I'm saying solving simultaneous equations. I'll show you two different ways of doing it on the graphics calculator. But before I do that, I guess it's also important to understand that these equations will either be written in standard form or slope-intercept form. Now, in standard form, you've essentially got the x and y variables on the same side of an equation, and in slope-intercept form, you've actually got y and x on separate sides of the equation, and more specifically, y is the subject of this formula. So y is basically the variable that's on its own on the left-hand side, or even the right-hand side of the equation, but it's the subject. There's no coefficient of y. It's just by itself on one side of the equation. Okay, so that's the difference between standard form and slope-intercept form. Understanding that's important because the first technique I'm going to show you using graphics calculator to solving this simultaneous equation, I'm going to show you how to do it graphically. And I guess the importance there is that to solve it graphically using the graphics calculator, you need to have your or both of your equations, okay, in this slope-intercept form where y is the subject. So what I'm going to write here is that you need to rearrange your equations, or equation one or both of those equations, so that they are in the slope-intercept form. Okay, so when I look at these two equations, y equals 3x take 7, it's already in that slope-intercept form. Y equals 3x take 7, already there, so I don't need to rearrange it, which is fantastic. But this second equation, 2x plus y equals 11, is in that standard form, so I'll need to rearrange this one. Okay, so I'm just going to write that equation down. 2x plus y equals 11. And what I'm going to do is I'm going to rearrange it so that I remove this 2x from the left-hand side of the equation, and then the y is by itself, or the subject, on one side of the equation. Now, there's multiple ways to do it. The way I teach it and seem to explain it with a little bit more success is simply by keeping the equation balanced. So whatever I do to one side of the equation, I do the other side of the equation. So to get rid of 2x from the left-hand side of the equation, to make the value of 2x 0 on the left-hand side of the equation, I'm simply going to subtract 2x from the left-hand side of the equation. But to maintain balance, I'm also going to subtract 2x from the right-hand side of that equation. So that now is equal to 0 on the left-hand side. I'm left with y equals 11 take 2x. Okay. Now, I could write it in the form of y equals minus 2x plus 11, which looks more like this, but this is still essentially slope-intercept form. Okay, y is the subject by itself, and I can actually put that straight into the graphics calculator like that, or I could put it in like this, y equals minus 2x plus 11. Okay, I'm just, I guess, shuffling those two terms around on the right-hand side. Either is fine. Okay, so now that I have my two equations, let's go ahead and highlight those that are in slope-intercept form. In fact, let's use that one. I can then solve these graphically using my graphics calculator. So I open up the graphics calculator, I'll just take you back to the menu here. So we are going to use the graph function. Okay, oops. And once you're in there, hit execute. So first thing you're going to do is put in your equation y equals 3x take 7. So in my y1, so y equals 3x take 7. Hit execute. My second equation is y equals 11 take 2x. So y equals 11 subtract 2x. Again, hit execute. I'm going to draw those two equations, and it'll actually draw it on the Cartesian plane for you, and you should be able to see the point of intersection. Now that isn't on an exact number, so to get the exact answer, I'm actually going to press F5, which is the G solve button, and then I'm going to ask for the intersect point. So I'll go ahead and press F5 again, and then it tells me that the coordinates of the intersection are 3.6, 3.8, or x equals 3.6 and y equals 3.8. So that is my solution. X equals 3.6 and y equals 3.8. Okay, so once they're in that slope-intercept form where y is the subject, I can put them into the graphics calculator in that graph function, get the graphics calculator, draw the line, find the point of intersection, and that's my solution. Now, I showed you how to rearrange a pretty simple equation there, so 2x plus y equals 11. It's pretty straightforward because there's really only one step. Before I show you this second method of using the equation solver and the graphics calculator, I'm just going to quickly run through a little bit more, I guess, complex question that might pop up. So let's just get rid of that and write in, for example, 2x. Let's do take 5y equals, I don't know, 20. Okay. Now that there is a minus 5 in front of that y, I also have a second step. First step is I still need to get rid of that 2x. So again, I'm just going to subtract 2x from both sides, okay? Because what we're looking to do is we're looking to, remember, put this into slope-intercept form, okay? So y is by itself on one side of the equation. So subtract 2x from both sides. I'm then left with minus 5y. Let's use blue. Minus 5y is equal to 20 take 2x. And then I have minus 5y on the left-hand side. I need to get rid of that minus 5. Now, I'm not going to add minus 5 because the operation between the coefficient and the variable is multiplication. So the opposite of multiplication is to divide. So divide by negative 5 on the left-hand side, if I maintain that in red, which means I divide by negative 5 on the right-hand side. I'm then left with y equals, that's not what I want, y equals 20 take 2x divided by minus 5. Now, I can go ahead and simplify this more, but I really don't need to. That equation there will go straight onto your graphics calculator using this fraction button. So I can just write it as, as is 20 take 2x all over negative 5, right? And that's fine. And it will draw the line for me. Okay, that's not a problem. I mean, feel free if you want to. You can obviously simplify that a little bit, but I think just understanding how to rearrange it so that y is by itself on one side of the equation is probably all you need to understand. Okay, so that's a little bit more complicated in terms of rearranging. You will probably come across one of those that you'll need to rearrange, just understanding, I guess, the process. So anyway, the second method I'm going to show you is using the equation solver on the graphics calculator to solve these simultaneous equations. And this time, in order to use the equation solver, the equations need to actually be in standard form. Okay, so you'll need to make sure you rearrange them into a standard form. Now, you'll notice that both of these equations are already in standard form. Okay, understand in standard form that A is the coefficient of the variable x, B is the coefficient of the variable y, and C is that constant term. So basically, if I can look at an equation in standard form and identify the values A, B, and C, then I can use my equation solver and my graphics calculator to actually solve that simultaneous equation. So I'm going to get out of the graph function, go back to the main menu here. I'm going to go use the equation function here. So just hop down to that. And we are solving simultaneous equations. So select F1. There are two unknowns, an x and a y. So click F1, which corresponds to two unknowns. And then for the first equation, I'm going to put in the values of A, B, and C. So the first equation, the value of A is 2. You execute. The value of B is -3. Remember, the term includes the symbol in front of it. And the value of C is 4. Again, hit execute. For the second equation, my values of A, B, and C are 3, 2, and 19 respectively. So go ahead and put those in. And then ask it to solve for us. My solutions are 5, 2, or x equals 5 and y equals 2. Okay, as simple as that. Now, I haven't shown you how to rearrange an equation that was in slope-intercept form back into standard form. So really quickly, I'll show you how to do that. But essentially, that's how you use your graphics calculator to solve simultaneous equations, either graphically or using the equation solver. Let's just quickly, before we wrap up here, put in an equation that is in slope-intercept form. So I'll make one up. Y equals, in fact, let's use this one here. Y equals 3x take 7. And to put it back into standard form, that looks like this. I basically want to keep the y on the left-hand side and bring this x term also over to the left-hand side. Okay, so in order to do that, to make 3x on the right-hand side equal to 0, you guessed it, I'm going to subtract 3x from the right-hand side, which means I'm also going to subtract 3x from the right-hand side, which means I'm also going to subtract 3x from the left-hand side, which gives me minus, in fact, let's use the black pen there, minus 3x plus y equals -7. There you go, it's in standard form. A is equal to -3, B is equal to 1, and C is equal to -7. So hopefully that helps. And that's it. Pretty straightforward, solving simultaneous equations using a graphics calculator. Thanks for watching.